All right, so we are back. Hope everybody is doing well today. So, couple of things. First thing up front, I posted an announcement on Canvas with a reminder and some things to keep in mind. So, as everybody knows, I record my lectures and I make them available on YouTube. They're posted publicly under a 223 playlist. I very deliberately do not show, student videos. I don't record chat windows. I don't bring up a list of participants. And when I accidentally glitch and do that, I edit it out of the recording before I post it. So there should be no, student information appearing in those videos. However, the administration sent out a note yesterday saying that they also consider recording students speaking as a potential privacy violation. So I sent out an announcement, and here's the setup. If during lecture you have a question and you don't want your voice recorded, you have a couple of options. Okay, the easiest option logistically is send me a message privately. Okay, and I have a window logged in that is called Nick Macias Questions. Okay, that's running on my phone. So if you send a private message to Nick Macias Questions, I should notice it at some point, and I will go ahead and read the question to the class and then respond to it as best I can. And you can, follow up by chatting on the chat window and so on. That's showing up on my phone. It won't show up on the screen. If you send a chat message to just Nick Macias, not Nick Macias Questions, I won't see it, okay, because that's not where I'm logged in. If you want to talk interactively, right, you can go ahead and ask a question and just ask me to stop the recording, and I will make a note of the time and I will chop it out of the video before I post. Hopefully that makes sense. If you got any questions or concerns about that, you can shoot me an email and we can follow up offline. Alright, so that's the first thing. Second thing, programming assignment 1. So I've got that from almost everybody. And some people had me look at their code ahead of time, and the ones I looked at looked really good. So I'm expecting great success on PA1 from everybody. I will get them graded sometime in the next few days. Normally I make programming assignments due Friday. I have the weekend to grade them. Not the case this quarter because it's a short quarter. So you turn it in on Tuesday morning. Don't necessarily expect you're going to get it back Wednesday morning. Okay, it's going to take me a few days since, it's not the weekend. But I will get them graded as soon as possible. And are there any lingering questions on PA1 on the even class? I'll go through your code, and if I see problems, I will give you some feedback in the comments on Canvas, and we can talk about it from there. All right, well, we are on to PA2. So let me bring up PA2. And as sometimes happens, this has a lot more words than it probably needs, but I'm trying to make it very clear. So this is an assignment about strings, hashes, linked lists, and as I mentioned yesterday, thinking about classes and objects as self-contained things. And in particular, putting classes inside classes, making an object that contains other objects, and nesting these things. And the same, disclaimers as PA1. This program is a lot more complex than PA1, but you're not necessarily going to need to write a lot of code. It's really how you write the code rather than how many lines of code you crank out. And if you're thinking of objects the way that I'm wanting you to, right, you'll start finding that one line of Java code does what might have taken you, 20 or 30 lines of C code. Okay? It's really about modularization and code reuse and taking advantage of what's already there. So big challenge here, which we talked about yesterday, thinking about objects as self-contained entities that include data and code. Okay, once you get into that mindset, it starts to feel almost like the code is writing itself, which is really fun. Okay, but it doesn't happen right away. And no matter how many hours you start working on this, it's probably not going to happen in one session. If you like load up on energy drinks and you just work on this for 20 hours nonstop, you probably still won't get to that aha moment. Okay, it takes working on it, backing away, thinking about it, sleeping on it, coming back, working on it some more, a few iterations, a few days. Okay, so again, absolutely start early on this. Again, don't use any IDEs. Keep working on the command line. Okay, the IDEs will, write your import statement for you. It will fill in your calls to methods and so on. I don't want you doing that. I want you looking at the Java documentation. I want you looking through the list of methods that are available in a hash map and deciding which ones you want to use, and looking at the description of them and saying, oh, here's another one that does something different. What does that do, right? I want you to get your hands dirty. IDEs really absolve you of that. You basically, sit down and you hit the first letter and boom, your code pops out and it's done, So I want you doing the process yourself. Okay, so what you're making is a class named Indexer. It's a single class. And with Indexer, you can do this word index thing that we did in previous quarters with War and Peace and such. Basically, when you create an indexer, you can feed it a file. It will pull words out of that file and record where each word is located in the file. Okay. So let me show you an example of using this, and then we'll talk about the details of how it should be implemented. So this is just sample main code, okay, and this is available on the Linux server now, along with a test file. Okay, let me show you the test file. This is a test, so it is, and so I say yes or no, time to test this. What will we do? Smiley face, test, 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 yes, goodbye. Okay. If everything is working perfectly, here's what you want your indexer to do. Take this file, pull out the words. This is a test, so it is. Okay, yes or no. Ignore punctuation, ignore commas, ignore things that are just, punctuation like smiley faces, ignore new lines, ignore spaces, just break out the words. Okay, and treat them all as uppercase. So uppercase T test, lowercase t test, same word. And then basically make a list of all the words in your file and the positions where they occur. So for example, the word this occurs in position 1. Okay, and the first word, we're counting that as position 1. This occurs in position 1. It also occurs down here in position 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So this occurs in 1 and 21, and I think that's it. Okay, and your indexer should build up that information and save it internally. So for example, it should know that this occurred at positions 1 and 21. Test occurs at positions 4, 20, 26, 27, and 28. Okay, here's the word test, here's the word test, and here's the last 3 occurrences of the word test. Okay, so it's like an index at the back of a book. For each word, we get a collection of locations where it occurs in the file. So starting with the first word being location 1, second word is location 2. Okay, that's the functionality we're after. You're going to implement the indexer class and a series of methods. Okay, so here's the details. Class has to be named indexer. You're only writing the indexer class, but write your own main programs to test it. See what it's doing along the way, and so on. Single constructor, which doesn't take any arguments, and it doesn't really do anything. Okay, it just constructs. A series of public methods. The biggest powerhouse is called process file. Process file takes the name of a file, and it could just be a file in your directory, or it could be a path name, right? Like /temp/testfile.txt. And it will attempt to open that file. If it fails, the function just returns false, saying I did not process a file. If it succeeds in opening the file, what it should do is read in the file, break the input on spaces, remove anything that's not a letter, convert everything to uppercase, and then add that word, each word that it finds, to this index that it's building. It doesn't print anything. It simply returns true, saying I processed a file. But internally it builds up this hash map, which is hashed on words, and with each word is associated a linked list of positions where the word occurs. Okay, so this is this hash map with two structures that we were playing with yesterday, and we'll play with more today and tomorrow. Alright, so process file does all of the heavy lifting. It opens the file, reads it in, breaks it up, cleans up the words, adds them to your growing index, which is a hash map. Okay, and then when it's done, close the file, return true. Okay, once you've built an index successfully, once you've opened a file and done all of that processing, you now have other methods you can call. Number of instances is a method. You give it a word, it tells you how many times that word occurs. So I've said number of instances and I pass it the word this, it would come back with 2. If I passed it the word test, it would come back with 5, using that previous example. Okay. If I've not succeeded in processing a file yet and I ask for the number of instances of a word, it should return -1. Okay. That's an error flag. If a word doesn't appear, just return 0. Location of lets me know where the nth occurrence of a word is. So suppose the word test, it appeared 5 times, right? If I call location of and I say test, 0, it should return the location where test appears for the first time. If I say location of test, 4, it will tell me where the 5th occurrence of test was, right? 4th, but we start from 0. Okay, and so on. If you call this and you pass it a number, an instance number that's less than 0, that's meaningless. If you pass it an instance number that's bigger than the number of times the word appears, that's meaningless. And if you haven't processed a file yet, that's meaningless. So in all those cases, return -1. Okay, that's your error return. Otherwise, return the location in your file where the word occurs. So for example, this was the index that was built up for the test file. So if I said location of no, 0, it should give me 17. If I say location of no, 1 or 2 or 3, it should give me -1 because it only occurred one time. If I say location of so, 0, it should give me 5. So, 1 should give me 8. So, 2 should give me 12. Okay, there's a really easy way to think about this. If this is the linked list associated with so, then asking for where the nth occurrence is just saying give me the nth element of this linked list, which you can do with a get method. You can say get parentheses n, and the linked list will return the nth entry in the list. Okay, so location of is really just a wrapper around linked list's get method. And most of these things are really just wrappers around methods that are already available to you. Okay, so that's location of. Yeah, I have run it with War and Peace actually, and it's not bad. It looks pretty cool. In fact, I'll show you what it looks like in a minute. And it's fast, right? These classes are pretty efficient. So that's location of. Number of words just tells you how many words are in the index. Again, if you haven't succeeded in processing a file yet, return -1. Otherwise, tell me how many words are in the index. And if you processed a file that had nothing in it, right, number of words would be 0. That's kind of an edge case, but it's okay. ToString should just return the ToString of your hash table. Okay, you've got a hash map which stores the index, just return that thing's toString. So you can return, you know, quote quote plus index or index.toString. And the result of the toString method will be, you know, something that looks like this. Not particularly user-friendly, but definitely human-readable, right? And for a small file, it's pretty easy to look at this and tell if you're putting your things in the right places. And there's no guarantee on the order of these things, right? They're not alphabetized. They're not based on when they're added. It's unpredictable because it's a hash, right? It depends on the hash function. All right. And then I want you to implement 2 private methods. These are methods that you're going to use internally, so I need to see these. And there's no limitation to the amount of data a hash map can handle. That's a question. Other than, you know, the memory of the Java virtual machine, which is normally a couple of gigabytes, give or take, but you can specify how much memory you want the JVM to have. And unless you run out of memory, pretty much you can just keep jamming more and more stuff into it. Same with linked lists, right? There's no inherent limit to the length of a linked list. It's a machine limit only. All right, so 2 private methods I want you to implement. The first is called cleanup word. It takes a string and returns a string. What does it do? It goes through the string, the input, character by character, and it uses this character is letter method to see whether each character is a letter or not. If it is, append it to an output string. If it's not, ignore it. Okay? So go through your input word and basically take everything that is a letter and append those all together to make an output string. Convert the output string to uppercase, return that as the method's value. So, you know, if you say cleanup word, and you pass in this string, it should say, okay, T is a letter, so we'll append that. H is a letter, so we'll append that. Not a letter, not a letter. I is a letter, we'll append that. Not a letter, not a letter. S is a letter, we'll append that. Dots aren't letters. Here's our output string converted to uppercase. That should be the return value from this input string. So it's doing the nice pre-processing cleansing of your file for you. Okay. Yes, you will need to import libraries for a linked list and for a hash map. And everything else should be built in. Oh, also for a file. We have to talk about files. And also for scanners. So yeah, you got some imports to do. So scanner, file, linked list, hash map, I think is it. I could go check my code, but then everybody would see it. And you don't need to import exceptions. They should come in when you import file. But yeah, we'll have to talk about exceptions too. All right, so that's one private method. The other private method is called add reference. This is the main one you're going to call. This is the only one that actually does any real work. Okay, but again, it's mostly wrappers. So add reference takes a word and a location and adds it to your index. Okay. So if the word is not already in the index, the hash map, add it with an empty linked list. Okay, and then add location to the end of the linked list associated with word. Okay, if the file has not been processed yet, if your hash map hasn't been set up, don't do anything. Okay, take no action and just return. None of these methods should ever print anything, and none of them should ever throw an exception. Okay, they all operate silently. ToString doesn't print anything, it returns a string. Okay, add reference doesn't print anything, it adds something to the index, and so on. The only field that you really need, which should be private, is a field called index. Okay, and index is an object of type hash map. That's the main structure that holds all of this information. Okay, and it's a hash map. It's keyed off of your words, and associated with each word is a piece of data, which is a linked list containing the locations of that word in the file. Okay, that's your whole structure. Other questions up to there? Okay, here's your whole program. This is pretty much all you have to code. So your process file needs to open the file using a scanner, and we'll play with that and see how to use scanner. We've talked about using scanner to read from standard in. It's almost as easy to read from a file. Okay, if an error occurs, just return false if you can't open the file. Otherwise, you've opened a scanner, right? Create a hash map named index, okay, with strings for keys and linked lists for values. Set an internal variable called position counter to 0. This is just a local variable. It doesn't have to be a class variable. It's just inside your process file method. Okay. Start reading words using has next and next. Okay. Don't use has next line and next line, because then you have to break the line up yourself, and you have to know when you get to the end that you have to go on to another line. That's way too complex. Use has next and next. We're going to play with these too. Those pull in one word at a time, where your words are separated by spaces. Okay, so has next, if it's true, call next, that gives you the next word. Just run that through cleanup word, take the result, that's the word you're dealing with. Okay, now if your original word was, something like this, when you clean that up, you're going to have an empty string, because nothing in here passed the, is it a letter test, and your output string is going to be empty. So make sure your word is not empty. How do you do that? Well, easiest way, just do word.length, make sure it's not 0. So length parenthesis parenthesis. You could string compare to quote quote, that would also work, right? String.equals parentheses quote quote. But probably the cleanest way, just see if word.length paren equals 0. If it's not empty, then do the following. Increment the position counter, so the first position counter we're going to use is 1, and then call your add reference method. Pass it the word, pass it position counter, and you're done. Right? Go back up, get the next word, clean it up. If it's not empty, increment the position counter, call add reference. So you're just going to loop through these 3 steps over and over and over again until you hit the end of the file. Has next comes back empty. At that point, close the scanner and just return true, and you're done. You've built your file. Okay, how does add reference work? Same thing I just said upstairs. Look at the word and see if it's in the index already. So use your get function. If it returns null, the word is not in your index, add it to your index. Okay, so put the word into your hash map, and the data you want to put in with it is an empty linked list. Okay, now whether the word was originally in there or not, you know the word is in there now, and there's a linked list associated with it. Add position counter to the end of that linked list. Okay, and it's really, one line. It's index dot get word, which retrieves a linked list from the hash map associated with word, right? So this is a linked list, and you can say dot add position counter, and that appends it to the end of the linked list associated with this word in the hash map. So you don't need to be doing any looping. You don't need to be doing, a lot of analysis of your data. All that stuff is managed for you. Okay. So we'll put some meat on these bones as we go through the week. But that's the basic setup. Okay. Cleanup word is a loop. That's just a single loop. Goes through your input character by character. Use character at, which some people were playing with talking about on Discord. Character at, right? 0 gives you the first character. N gives you the n plus first character. So loop up to word.length -1. So use this to pull off the nth character, and use character.isLetter to see if that thing is a letter or not. If it is, add it to an output string, and then return the output string. And everything else is like add reference, right? It's really just a wrapper around existing methods. So if you want to know how many words are in your index, it's just index.size, right? Look at the hash map documentation. There's a size method which says how many key data pairs are stored in this hash. Well, that's the number of unique words that you have. All right, so here's some sample code. Again, this is available on the server, but it's just prototype. You can do a lot more sophisticated testing. This was just, mainly to make sure that the code I wrote myself was working correctly. So here's some pathological tests, making sure that things don't blow up. We create an indexer, but we don't call process file. Okay, if I try to print out that index, it should know that the hash map is empty. If I try to look at the number of instances, right, that's an error. That should give me a -1. If I try to look at the location of a word, that should be -1. If I try to look at the number of words, that should be a -1. Okay, so when you run this, before you've built an index, the index is null, and all of these functions return -1. Okay, same thing after you process a file that you can't process. If you try to open a file that doesn't exist, right, again, the index is null and all these methods return -1. So I tried to open a file called badfile.bad, right? It should return false. All right, now if you open a file that does exist, this should return good. So let's look at the status. Let's go ahead and see what the index looks like. So using the toString method you're going to write, which is hashmaps toString. And then let's look for the number of instances of a word that's not in there, like bad, bad, bad. Let's look for the number of instances for a word that is in there. And then let's try our location of, and let's find the ith location of test, where I goes from -1 to the number of instances. And so this should throw errors on the end. And then let's see how many unique words there are in here by using the number of words method. So, same test file, just my usual test gibberish. So after we process the file, we look at the return value from process file. It's true. Okay, that's important. When we just print out the index, the indexer object with, its toString method, we get this thing. It's possible that when you do this, you'll get these things in a different order. I don't know if that's going to happen or not, but if it is, don't worry about that. Just make sure that the data is the same, that what has 22 and we has 24 and this has 1 and 21 and so on. And the number of instances of bad, bad, bad is 0. Test occurred 5 times. So if I ask for instance 0 through 4 of test, I should get good information, right? Instance 0, 1, 2, 3, 4. But if I ask for instance 5, that should give me an error. If I ask for instance -1, that should give me an error. And the number of unique words should give me 19. And if you count them up, you actually have 19 unique words in your file. All right, so that's just sample test code. You can do a lot more. You can make this interactive. And tell more things from that. Let's see, test file. Yes, I already did War and Peace. So pretty fast, right? 2020 unique words in the file. The word test occurred 8 times, but we can go through here and see Grote appeared once, whereas Bay appeared a bunch of times. Themselves, Sinking, Chief, Tranquil, So tranquil appeared twice and sinking returned all these times. So that kind of tells you what kind of story it is, right? Although there's a lot of laughing, apparently, and there's not a lot of rallying. So I don't know. It's an interesting analysis. I don't know what pleasure balls are. And things being born. So yeah, so it works on War and Peace, right? And that's a good test to make sure that you're not doing something that you shouldn't be. Just like in the previous versions of this assignment, you want to process the input as you're reading it, okay? Do not try to read the whole input file into memory. Number one, it's hard to do with large inputs, and number two, there's no reason in the world to do that. The only reason to save input in memory is if you need to go back and work through it, you know, at some point after you've read it. But everything you need to do in PA2 you can do at the moment you read a word. As soon as you get a word from the input, you can clean it up. You can see if it's in the hash. You can add it to the hash if necessary, and you can update the linked list associated with that word. And then you're done. You can throw that word out and move on to the next word. So don't try to store everything in memory. But if you do try to do that, right, there's a good chance War and Peace will blow up on you. So it's kind of a good test for that. And it's fun to analyze what words appear in there. All right, and there's a lot more you could do with this. It would be nice to be able to get a list of all the words in alphabetical order. It would be nice to be able to, you know, see which words occur most often and so on. You're welcome to embellish this, right? But make sure that what you turn in conforms to this specification. All right, so let's talk about grading. So first of all, right, I'm going to download from CSE223pa2.git. This is due, I believe, a week from Friday, but check Canvas to make sure, and it should be 8 a.m. as usual. So I will download then. Make sure it's in Git, make sure it's named correctly, make sure your file is in the top level of the repository, and make sure I'm a reporter, okay? All right, so points, 100 points total. If I can download your project and compile it, you get 20 points out of 100. Okay, so that's for doing anything. If you define an indexer class, meaning that you spelled it correctly, you get another 5 points. So there's 25 points. If your process file will ingest the file that I give it and at least store some of the cleaned up words in the hash map, that's worth 10 points. Okay, if it's missing words, if it's you know not able to put them in a hash map or something, right? But if it's doing something, right, there's 10 more points there. If you also associate a linked list that contains at least one of the location of some of the words, right, that's 5 points. So if you have any kind of linked list in there and you're at least putting in, you know, one of the locations, that's fine, 5 points. If you can save all of the words in the hash map, right, that's another 5 points. And if you save all of the words and the linked list with all the locations, that's 5 more points. Okay, so at this point you're up to 5, 10, 15, 25, 30, 50 points. Okay, basically for getting your process file to work and everything that needs to happen up to that point. So that's half your points. Tostring, number of words, number of instances, and location of, 5 points each. Okay, so that's up to 70 points. Not blowing up when you try to work with something that you haven't initialized yet, like you try to process a file and it doesn't succeed. And I try to say how many words are there in the index anyway, right? It shouldn't throw an exception. It should give me back my -1. So if all of that exception handling is done correctly, 5 points for that. And then if you implement those 2 private methods correctly, 10 points total. All right, so that's 85 points and then 15 points for style. Same guidelines as on PA1. Okay, so consistent indenting, placement, and so on. All code commented. In this program, right, you're not going to be writing a whole lot of you know, looping, a whole lot of I = I + 1. It's really going to be, you know, a few lines of code, very carefully chosen. Those are going to want to be commented. Okay, if I don't see comments on there, you're going to lose the 15 points. And you should feel like you need to comment this for yourself. Okay, these classes are really powerful, right? and why do I call, index.get parentheses word.add parentheses position? There's like 15 things going on in that one statement, right? Talk about it, right? Or break it up, You could say, temporary linked list equals index.get word, and then temporary linked list.add position, right? So document it for yourself, right, as well as me. All right, so that's the grading rubric, submission, CSE 223 PA2. Put it in the top level of the repository. But if you want to have other files in there, subdirectories and so on, you're welcome to do that. Because I keep saying that you should set up this repository and then just push everything over anytime you make a change. But if you do that, you're going to get all kinds of temporary files and so on. So that's an unfair expectation on my part. So you can put anything in there you want, as long as at the top level directory I find indexer.java. Okay, and that's the file I'll look at, and I'll just ignore everything else that's in there. Okay, unless you put a README in, which I'll assume you want me to read. That's pretty much it. The description of the assignment is way longer than the solution. Okay, the solution is much fewer lines, but I'm trying to be exhaustively complete in the description, so hopefully I've got everything covered in there. All right, other questions on this? There's been some chat questions. Any other questions? This seems to work well for me, having my chat window up on my phone, except Zoom doesn't rotate, so I've got to keep my head tilted when I want to read chat messages. But that's my 21st century problem. Yes, you can have any extra private variables that you want. But in general, don't make them class variables unless they really need to be class variables, right? A class variable is basically like a global. So when you define something in the top of your class outside of a method, it's global to the whole class. And same concern with globals in any program, right? It can lead to kind of sloppy coding, and it can lead to errors because you're stepping out of a local variable with the same name or something. But if it makes sense to make it global, yeah, that's absolutely fine. And in general, on all these assignments, whatever you want to add in the implementation is totally fine, right? And anything you add that's private doesn't affect the user who's using your class, and so that's fine. So yeah, feel free, whatever makes sense. Can classes in Java use global variables? They kind of do. So for example, right? So like here's my even class. This int val is a global variable within this class, right? Every method in here can access this by saying val, val, val. But they're not evil somehow because they're constrained to this class, right? So yeah, that's totally legit. And in my main program, you can have globals as well, because your main program is sitting inside a class. So if I define a variable right here, right, that's going to be global to everything in here. So like if you create one in the main file, then the class can't interact with that. Right, so if it's defined inside a class, the only way that another class can get to it is if it has an instance of that class and it says instance name dot variable. Or you make like an accessor and it says instance name dot get variable. All right. So we played with the scanner class already, and I've given you a big hint that you want to use has next and next. Okay, so has next tells you whether there's another token, and then next returns it. And tokens by default are things separated by spaces. Okay, that's really what you want. You just want to pull in everything up to the next space, including a new line or an end of file as a space. So just do scanner.has next, right? And word equals next or something like that. But we want to read from a file, right? The file name that's passed to the processor. So when you construct your scanner, instead of constructing off system.in, you're going to construct by passing it a file. So easiest way to do this is to pass it a file object, and it's pretty straightforward. So you can say scanner sc equals new scanner, and if you want to pass it a file name, you can say new file, and you can put the name of the file in quotes. And there's multiple constructions happening here. This is creating what's called a file object, which will let you interact with this file on disk. And that file object is a legitimate argument to pass to the constructor of scanner. And so when this all comes back, sc is a scanner object that's reading from this file. So if I say sc.next, it'll read the next token from that file. And so file is, its own class. It imports from java.io.file. And you can construct a file by giving it a path name. Okay, so create a new file instance by converting the given path name string into an abstract path name. So that's basically how you create it. The one detail we're going to have to go through, though, is that when you construct, it's possible for this thing to throw an exception. Okay, it'll throw an exception, well, not when you construct it, but when you try to create the scanner off of it, it can throw an exception. And so we have to talk about exceptions, and we'll do that tomorrow. We'll start off by talking about errors that can occur and how to manage them. Okay, because if something goes wrong, so here's where we construct off of a file name. Okay, so if that file doesn't exist or it's not accessible, this will throw an exception, and it will throw up all over your screen. So we'll talk tomorrow about how you deal with exceptions, and then we'll do some examples of scanning from a file, and then we'll start playing with some strings and get some ideas how to work with those. All right, that's all I got today. I will see you next time.